Hello students, welcome to Narayan College online classes. So in the last video we have discussed up to the 35 questions in the level 2 and today we will discuss remaining questions here. Clear? See the question number 36. Clear? So which amongst the following reactions cannot be used for the preparation of halogen acids? Halogen acids means HCl, HBr, HF those. Yeah. So which HCl, HBr, HI, clear ma? So which of the following reaction cannot be used? Clear? First reaction they have given 2 KBr plus H2SO4. It gives concentrated H2SO4. It gives K2SO4 and plus HBr. H2SO4 plus 1 is not HBr. Second reaction NaCl. Clear? So 2 NaCl plus H2SO4. Same here also H2SO4 they have given and it gives NaHSO4. NaHSO4 plus what is it? HCl. And the third one NaHSO4 sodium bisulfate and treated with the NaCl and it gives here Na2SO4 Na2SO4 plus what it is HCl. And next one is CaF2 clear and plus H2SO4 clear is giving rise to H2SO4 is giving rise to CaSO4 plus what it is here H, which cannot be used to prepare the compound. Clear? You see, in all the cases, you have prepared HBr, HCl, HCl and HF. But one of the method is there that is wrong. We cannot prepare. So which one that you have to find out? Clear? So in this case, you see, you already know that H2SO4 is a oxidizing agent. It what it is here? Oxidizing agent. It oxidizes easily HCl, HBr and HI. HBr and what it is here? HI. Why? Because you know that reducing agent means this is the reducing power or HCl, HBr and what it is HCl. HI, HBr and HCl. This is the reducing power means it is powerful reducing agent. It is a powerful reducing agent means it easily undergo oxidation. It easily undergo oxidation or not? If any oxidizing agent is there and it easily oxidized to iodine, it easily oxidized to bromine compared to what is HCl cannot be easily oxidized. Clear? So that's why HCl and HF are there and they are weak reducing agents. They cannot easily oxidized in the presence of oxidizing agents. Clear? So that's why in this case we treated this KBr with the H2SO4. We got what is HBr, but HBr easily undergo oxidation in presence of which one? Oxidizing agent. What we have used here H2SO4. It is act as a oxidizing agent after forming of HBr and unreacted H2SO4 and oxidizes the HBr into what it is bromine. So we cannot prepare HBr in this reaction. Clear? But here you may ask, sir, HCl is there H2SO4 and HCl is also oxidized, but it is not easily oxidized by the H2SO4. Which one is oxidized? HI and HCl. So that's why, and this method can be used to prepare HCl, and this method also can be used to prepare HCl, and this method also can be used to prepare the HF. But HF, it won't be easily oxidized in presence of H2SO4. So your option should be what it is here. Option 1 is the clear. Next question. 37. Which of the following family does not show positive oxidation state? So which one will not show the positive oxidation state? Fluorine, it is being a highest electronegative element means it is a highly electronegative element, so that's why it never shows the positive oxidation state. Clear? So option 1 is the correct one. The inert gases can be isolated and separated by. Clear? So we have methods for separation of what it is here inert gases. Clear? So we can separate them by adsorption of charcoal. Different noble gases adsorbed on the charcoal at different temperatures. Clear? Adsorption and also fractional distillation. First, what we will do, we will reaction mixture is there. All our gases, we will cool the gases, then they are converted into liquid form, and you know they depend upon their boiling points. We can easily separate it out the individual noble gases. Okay, so we have two methods. One is fractional distillation of liquid A and adsorption on charcoal. So both second and third methods are used to isolate and separated by, means separate, we can separate the noble gases. Clear? So that is 38. Option 4 is the correct one. 39. Which of the following noble gas was reacted with platinum hexafluoride by Bartlett to prepare the first noble gas compound? What is the first noble gas compound? Xenon reacted with platinum hexafluoride, and we got the xenon, hexafluoroplatinate. Clear, no? This is. So which noble gas is involved to form this first noble gas compound? Noble gas compound, that is xenon. So option 2 is the correct one. Clear, no? Helium oxygen mixture is used by deep sea divers in the preference to nitrogen oxygen mixture, because I already mentioned so many times nitrogen easily dissolved in the blood when we are in the water. Clear? Because when we are in the water, pressure will increase. So you know that nitrogen gas easily dissolves in our blood. Clear? So when we come to the surface of the water, then pressure decreases, and this means dissolved nitrogen try to come out from the blood cells. Clear? So that time we will get pain. So that pain we will call as a pain. So we have already studied this one in the solution chapter also. So instead of nitrogen, what we are using nowadays, helium and oxygen, because helium, it will not dissolve in our blood. Clear? That is to dilute oxygen. That's all. Next one, that is option 1 is the correct one. Which of the following two are isostextural? Very important, I already said. Isostextural. Isostexturals means what it means? They should have the same structures, same shapes, you can say. So when the molecule will have the same shape or structures, when they have the means equal bond pairs and lone pairs. Clear? So calculate the bond pairs and lone pairs, then you can easily understand. See, clear? So first one is XeF2. Clear? XeF2. So I already mentioned how to calculate the bond pairs and lone pairs. What is the central atom here? Xenon. Xenon belongs to which group? 8 group. How many electrons you have to write? Write 8 electrons. And xenon, for how many fluorine atoms are there? 2 fluorine atoms. To form 2 bonds, xenon has to use how many electrons here? 2 electrons. So remaining electrons are what it is now. So pairwise you write. Clear? So these we will call as a bond pairs, and these we will call as a lone pair. So how many bond pairs are there? 2 bond pairs and 3 lone pairs. This is structure. Means this is the bond pairs and lone pairs. IF2 you calculate. IF2 minus iodine belongs to which group? 7. Right here 7 electrons. But here negative charge is there. 1 electron should be added. Add 1 electron. Total how many are there? 8. So how many bonds it has to form? 2 bonds it has to form. 2 bonds to form. It will iodine will use 2 electrons. Clear? And here what is there? You see there is a 2 bond pairs and 3 lone pairs here also. So 2 bond pairs, 2 lone pairs. Here also 2 bond pairs and 2 lone pairs. Both are same. Same means what it is here? Same number of bond pairs and lone pairs are there. It will have the same structure. It is whenever I said whenever lone pairs are greater than bond pairs, the shape of the molecule will be linear. Clear? No? So that's why it is what is the shape? Linear. Here also what it is? Linear. So first option only. Second one also you can do in the same way. Clear? No? So option 1 is the correct answer. Next one. Clear? No? So next one is see here 42%. The ease of liquefaction of noble gases decreases in the order. Ease of liquefaction. Clear? You know that all are gases only. And which one easily, which gas, they are asking the order of the liquefaction. They has to, gas should be converted into what is called liquid. When gas will convert into liquid, when there are attraction forces are there among the gases molecules, they come close to each other and they convert it into liquid. Clear? So you know that if you are moving from helium, neon, argon, krypton, xenon and radon, when we are moving top to bottom from the neon, helium to argon, the size increases. As the size increases, van der Waals forces also increases. Van der Waals forces of attraction increases. When attractions increases, van der Waals forces means what? Attraction forces only. When attraction forces increases, gas molecules easily liquefies. So which one will have the, which gas can easily liquefy here? So according to they have given radon, they have not given. So which gas easily liquefies? Xenon. Why? Xenon is compared to other noble gases, and here xenon is large in size. So that's why among the xenon atoms, and van der Waals forces of attractions are more, so easily liquefy. So what should be the order here? This is the order. Clear? So your option 2 is the correct one. 43. Which of the following is an explosive compound? I already mentioned xenon trioxide is a explosive compound. Clear? So for next one, 44. The forces acting between the noble atoms are, I already mentioned here, London forces are dispersion forces. My exact word means it is a London forces. Clear? London are dispersion forces. That we can call weak van der Waals forces also. Clear? But exact terminology if you wanted to use here, dispersion forces are, what it is here? London forces. So HCl4 on hydrolysis, partial hydrolysis produces. Clear? HCl4 on partial hydrolysis. Partial hydrolysis means, and here fluorine atoms won't be removed completely. So what it is, two hydrogens are there, and 2 F molecule will be removed as a 2 HF, and remaining what is left here? Here xenon is left. Here which one is left? Oxygen is left. How many fluorine atoms are there? 2 fluorine atoms. This is answer. So your option should be XeO. And this is about the level 2 questions. And now we have here some NEET and AMT questions that also we discuss. So here some AMT questions and NEET questions they have given here. See from the 16th group elements, the first question. Yeah. So sulfur trioxide can be obtained by which of the following reaction? By which of the following reaction? Clear? So sulfur trioxide can be obtained means for they have given 4 reactions here. Which reaction is used to prepare the sulfur dioxide? That is the first one. And another one here, H2SO4 and PCl5. This is the second one. And CaSO4 and plus carbon and heating. And next one is Fe2SO4 thrice and here heating. So which reaction is used to prepare the sulfur dioxide? We have in our syllabus sulfur dioxide we have discussed, but here they have given the question on the based on sulfur trioxide. Clear? So whenever sulfur, when it is reacting with H2SO4, H2SO4 is oxidizing agent. When oxidizing agent is there, sulfur is converted to sulfur dioxide. So sulfur dioxide plus what we will get? H2. This is, so I am not balancing here. Just the sulfur is converted to sulfur dioxide and hydrogen and oxygen will be removed as a H2. This we have already discussed, H2SO4 and PCl5. And PCl5 is used where, for which purpose we will use the PCl5? For chlorination. Means chlorine atoms will be added when the compound is having the OH groups. Whenever any compound is having OH group and that compound when reacted with the PCl5 and the OH group will be replaced by the chlorine groups. Clear? So that is, we have in the sulfur, sulfuric acid formula. This is the sulfuric acid. So that's why how many OH groups are present here? 2 OH groups. When it reacted with PCl5, 2 moles of PCl5. Clear? So 1 chlorine will be replaced one OH, and another p sulfide, another chlorine will be replaced with the OH. Then what you will get here? You will get sulfuryl chloride, SO2Cl2, direct line right here, SO2Cl2, and 2 moles of POCl3 and 2 moles of HCl. We have already discussed this reaction. So next one. So whenever calcium sulfate plus carbon, what the reaction over here? What the reaction you will get? You will get the compound is, one is calcium oxide, another one is carbon dioxide, and another one is sulfur dioxide. This is sulfur dioxide, and another one is calcium oxide plus what it is carbon dioxide. We have to balance, but balancing is not required here. Just what are the products? When you heat this, these are the heating mode. When you heat this, and this compound, it decomposes and gives the sulfur dioxide, and also what it is we have calcium oxide, and it releases some oxygens, and that oxygens carbon it takes and converts it to carbon dioxide. So whenever sulfate, this is ferric sulfate. Clear? What is the oxidation state here? +3. So whenever ferric sulfate heated, then what it will give? Same like here sulfates are there and they are converted. Whenever sulfates, if you heat at very high temperature, they are converted into their respective oxides. Calcium sulfate is there. If you heat, you will get one of the product, what is calcium oxide. In the same way, ferric sulfate, if you heat, you will get the compound is ferric oxide, Fe2O3, and plus you will get here SO3. This is important. So this is the compound which is used to prepare the sulfur trioxide. In remaining all cases, we will get what it is. First one is sulfur dioxide. Here sulfuryl chloride, and in this case you will get sulfur dioxide. And whenever +3 is there, and it will give the SO3. +2 is there, it will give always SO. That we know. Clear? No? So second question. Coming to this is first question. Clear? Next one is question number 2. So which of the following does not give oxygen on heating? Clear? So this type of questions are very, very important. So which of the following does not give the, what it is here, oxygen on heating? So we have here, first one is ammonium dichromate. Very clearly we have mentioned, whenever the decomposition of ammonium dichromate, you will get the nitrogen. What you will get from here? Nitrogen. What is the nitrogen here? N2 and plus oxygen here Cr2O3 plus what you will get? H2O. This is balanced also we have discussed, because here nitrogen is there, ammonia, so it will give the which gas one? Nitrogen gas. Remaining all gives the oxygen. If I take here potassium dichromate, if you heat here, you will get K2Cr O4 and Cr2O3 plus you will get oxygen. Clear? And next one, zinc chloride ZnClO3 twice. So what you will get? You will get ZnCl2 plus and 3 moles of oxygen. In the same way, KCl3, this is also we have discussed. If you heat this, take the 2 moles and 2 KCl plus what you will get? 3 O2. And in 3 cases we are getting oxygen, but in the second case we are getting what is here? Nitrogen. So that is, what is your option mark? Which of the following does not give the oxygen on heating means the first one will not give the oxygen, it gives the what it is nitrogen. Third question. Which of the following, which of the statement given below is incorrect? Clear? ONF is isoelectronic with O2N. Isoelectronic means what it is? Same number of electrons it should have. Clear? If you take oxygen, ONF is there. How many electrons are there? Oxygen. Oxygen, what is the atomic number? Oxygen atomic number is 8, so that's 5. It will have 8 electrons. Nitrogen 7 and fluorine 9. So total how many electrons are there? 8 plus 7, 15. 15 plus 9, 24 electrons are there. And O2N minus. Here oxygen is how much? 8. 8 into 2 plus 7 plus 1. Negative means what? 1 electron. 16 plus 7 plus 1. 16 plus 8. How much more here? 24. So both are having same number of electrons. So these two species we will call as a isoelectronic. Clear? So next one. OF2 is an oxide of fluorine. What it is they mentioned? OF2 is oxide of fluorine. Clear? So I already mentioned these are OF2 is a clear one. So fluorine oxides. Clear what it is? So we have to call, we should not call oxide of what it is here, fluorine. That I already mentioned. So option 2 is the what it is here, correct one. Clear? So third question I already mentioned. OF2 is a oxide of fluorine they have given. So it is not. It is a oxygen fluorides, not oxides. These are. Because fluorine is more electronegative than oxygen. Fluorine gets which charge? Negative charge. Negative charge means we have to call that one as a fluorides, not oxides. Clear? So that I have already given. Coming to the 17th group, fourth question. Which one of the following present as a active ingredient in the bleaching powder for bleaching action? What is that? I already mentioned so many times. What is it? Calcium hypochlorite. CaOCl. This is the main one. Clear? Next one. And the fifth one. Variation of boiling points of hydrogen halides in the order HF, HI, HBr and HCl. What is here? Boiling point order it is. They mentioned. Clear? So what is the what explained that higher boiling point of hydrogen fluoride? Actually, you know that if I take this, we have already discussed HF, HCl, HBr and HI. As you are moving from the HF to HI, size increases, van der Waals forces increases, then boiling point should also increase. So this one should have highest boiling point here, HI, but here HF is having high boiling point because of which one? Hydrogen bonding. HF can form which one? Hydrogen bonding, but other halogen acids cannot. Clear? So that's why. What is the option here? There is a strong hydrogen bonding between the HF molecules. That is option 4 is the correct one. Next one, sixth one. Among the following, the correct order of acidity is. Same question we have discussed in the PU part also. Acidity. What they have given here? HCl4, HClO3, and HClO2, and what another one is HClO2 and HClO. Oxyacids of chlorine. So these all are, oxoacids of same element. That is what it is called, chlorine. Whenever same element is there, how to identify the which one is more acidic means, you know that acidic character is directly proportional to what is called oxidation number. If different halogen atoms are there, you have to, means acidity will be determined by the electronegativity. But here same elements, so that's why +7 and here +5 and here +3 and here +1, which is having highest oxidation state, HCl4. So that's why it is the strongest acid. So they are asking here, so which one is the correct one? Clear? So what is your option now? You can see option 3 is the correct one. Clear? Next one, seventh one. Which of the following order is correct for the bond dissociation enthalpy? So many times we have discussed bond dissociation enthalpy. Which one now? Chlorine is greater than bromine, and fluorine comes here. And what is iodine? Why fluorine? Actually, fluorine should have the highest bond dissociation enthalpy values, but and being a small size of fluorine atom, when they between the fluorine and fluorine bond is very short, so they come very close to each other, so maximum lone pair repulsion it experience, so that it is not a, means the bond between the fluorine and fluorine is not that much strong. So which one is having the strongest bond dissociation enthalpy? Fluorine will comes here. So this is about questions of 17th group. And last one, 18th group. 18th group they have given matching here. All we have discussed in the previous only. What is the structure of XeF6 one? XeF6 distorted octahedral. XeO3 structure what? I have given in the PU when we discussed about the PU1 table also I have given there. XeO, if you don't know, then you can calculate easily a shortcut I mentioned here. How many bond pairs are there, lone pairs are there. If you know the bond pairs and lone pair, if you have the knowledge about the table, clear? So in the first year it is there in the chemical bonding, you can easily identify what is the shape of the molecule. Clear? So XeO3 is there. XeO3 pyramidal structure. XeOF4, it is a square pyramidal structure. and XCF4 is a pyramidal shape. Clear ma? So that is your, and first one is clear ma? So in this case, 8th question, option 2 is the correct one. Clear? Next one. Same way for the 9th one also they have given among the what it is here inter-halogen compounds, and they have asking here structures. Clear? And x dash I already mentioned it is a linear shape, and x3 it is a T shape, and x5 it is a square pyramidal, and x7 pentagonal tripyramidal. Clear? Same the structures I have already mentioned how to calculate. There also I have given number of lone pairs and number of bond pairs. You just go and watch that. Clear? And next one, 10th. Clear? Question number 10. In which of following pair of ions both species contains S and S bond? SS bond is there. Which of the compound is having this bond? First one they have mentioned S4 O6 2 minus. 2 minus means for our understanding purpose, shall I write my here H2? If 2H plus removed, then you will get. If it is dissociated, how you will get 2H plus S4O6 2 minus. You may get confused. S4O6 2 minus means. So that's why I have written what is H2 S4O6. So write the structure. You know that here dithionic acid. So this is sulfur and sulfur. First of all, double bond O and OH you have to put. Double bond O and OH you have to put. Next one you have to arrange 2 hydrogens over 4 sulfurs are there here. Clear? So here there is 2 sulfurs. Clear? So how many oxygens are there? Oxygens are, what did they have mentioned here? S4 and then S4 they have mentioned here O. Clear? See now, same if I write here H2S4, first of all sulfur, and here what is OH. If I write here S double bond O and OH, then 4 sulfurs are there, and if I write here sulfurs, then and 2 oxygens left here, we have used how many oxygens here? 4 oxygens, but here how many oxygens are there? 6 oxygens are there. So that's why this is what is the structure you have to write, and here put the double bond, and then the middle there will be a sulfur, and this is the. So which bond is there here? SS bond is present or not? That is clear. In the same way, if you write here Na2H2 S2 O3 H2S2O3 H2SO4 is there, sulfuric acid and thiosulfuric acid. So what it will be there? There will be a double bond. Oh, this is actually sulfuric acid. This is what it is, sulfuric acid. Remove one oxygen and put one sulfur. So you will get what it is. You know this is thiosulfuric acid. Here also SS bond is there or not? SS bond is there. Here also which bond is there? Yes, S bonds are there. So these two are the options. And remaining this is you can easily identify the answer without doing also, without writing these pictures also you can easily identify. Why? Because you see, and second option what is there? H2S2O7. They have given S2O7 2 minus. I am writing H2S2O7. What it is? Oleum. Oleum means what it is? Pyrosulfuric acid. Pyro is there. Definitely there will be a S bond will be there. But they are asking what it is? SS bond. So that's why S2. This is oleum is there. Remaining 3 options. So your option first one is the what it is? Correct one. So which of the following statement? Next one, 11th question. Which of the following statement is not true for halogens? All form monobasic oxy acids. All are oxidizing agents. You know, all are oxidizing agents only. All but fluorine shows the positive oxidation state. That is also correct. Chlorine has highest electron gain enthalpy. You know that is fluorine and chlorine. Which one is having highest electron gain enthalpy? Chlorine is having highest gain enthalpy. So option 1 is the wrong. All forms mono, basic oxides. No, not monobasic oxides. Clear? So this is what it is here. All are oxidizing agents. All are which one here? All are oxidizing agents only. So that's why they can form monobasic, or sometimes they can also form dibasic also. Clear? So what it is here? All monobasic oxo acids only. That is wrong. So next one, 12th one. The correct order of N compounds in its decreasing order of oxidation state. Clear? Oxidation state, you know how to calculate oxidation state, and just calculate the oxidation state and you will get, and decreasing order you have to see. Clear? Okay, that is the next one. Question number 13. This is important question. Clear? So in this one, you know what they have given? A mixture of 2.3 grams of formic acid and 4.5 grams of oxalic acid is treated with H2SO4. Is treated with what it is here? H2SO4. The evolved gaseous mixtures is passed through the KOH pellets. Clear? So whenever you have studied in the first year, and when KOH pellets are there, and KOH pellets absorbs the which gas? Carbon dioxide gas. Clear? That is important. Weight of the remaining product at the STP will be. Clear? See, the first one is formic acid. What is the formic acid formula? HCOOH. It is treated with which one? H2SO4. You know, concentrated H2SO4 is act as a dehydrating agent, and it removes the what it is one here water molecule, and it gives H2O means CO will give. And formic acid means what it is? HCOOH, and here H2SO4 means what you will get the compound here? You get CO plus CO2 plus what it is H2. And the evolved gases here, what is that one? CO2 gas and CO gas and CO2 gas. Because these H2O molecules are absorbed by the which one? H2SO4. H2SO4 will absorb the H2O molecules. Remaining what are the gases here? CO, and what it is? CO2. Clear? And these gases, CO, CO2, and because water is absorbed by which one? H2SO4. CO here, CO and CO2 is passed through the which one? KOH. When we pass it through the KOH absorbs the which gas here? Carbon dioxide gas. Then which one will be left here? CO only. How many moles on here? 2 moles CO will be left here. Clear? Finally, they are asking what is this is? What is the clear here? Gas means you can say CO plus CO plus, and here also CO. So how many moles are here? How many moles are here? You have to identify. Clear? You know that HCOOH, how many grams they have given here? HCOOH, they have given 2.3 grams. If you calculate oxidation means atomic means molecular mass, how much you will get? Carbon is 12, oxygen is 16 means 32, and 2 you will get 46. Clear? So atomic mass is what is here? 46. And how to calculate number of moles? And weight by atomic weight means what you will get? 0.05 mole. Clear? So this is 0.05 mole. And COOH, they have given number of moles of COOH twice. Mass of this, how much they have given? 4.5 grams. If you calculate this, you will get the 90 grams. Then what you will get? You will get this 0.05 moles. Clear? See, this is simple now. I will write very clearly. You understand now what is this one? See now. This is 0.05 moles. When it is treated with H2SO4, what you will get? CO plus H2. So this is 0.05 moles. After reaction, this totally consumed, then how many moles you will get? 0.05 moles of CO and 0.05 moles of what is H2. Clear? It is totally converted to CO, and but this O is absorbed by which one? H2SO4. Here also 0.05 moles of this when treated with H2SO4, then what you will get? CO plus CO2 plus H2. When it is totally consumed, how many moles consumed? Those many moles will be formed here. 0.05 moles of CO and 0.05 moles of CO2 and 0.05 moles of what it is? H2O. And this H2O and these moles are absorbed by which one? H2SO4. And this CO2 moles are absorbed by which one? Here, KOH. So which one left here? We have CO here, 0.05 moles of CO and another 0.05 moles of CO. Total how many moles of CO finally left here? Finally 0.05 moles plus 0.05 moles. How much? 0.1 mole of CO is left. But they are asking what it is. Weight asking. Weight means what it is? moles into molecular weight how much here? 28 means 2.8 grams. This is the answer. Clear now? So this is about what it is now? Question number 13. So in the structure of ClF3, the number of lone pairs of electrons on the central atom. See, they are often lone pairs. I already mentioned how to calculate this is Cl and F3. Clear now? So chlorine belongs to which group? Here what is the central atom? Chlorine belongs to which group? 7 group means how many electrons you have to write here? 7 electrons you write. Clear now? So chlorine is forming how many bonds? 3 bonds. 3 bonds means chlorine to form 3 bonds. Chlorine should use how many electrons? 3 electrons. So 1 electron for one chlorine, another electron for another chlorine, and another electron for another chlorine. Which are left? Those we will write as a pairs. These are how many bond pairs? 3 bond pairs. And how many lone pairs are there? 2 lone pairs. So they are asking how many lone pairs they are asking. How many lone pairs? 2 lone pairs there. That is answer. So option 2 is the correct one. So which oxide of nitrogen is not a common pollutant introduced into the atmosphere both due to the natural and human activity? Which is not a common pollutant? You know, NO, N2O and NO2, these all are common pollutants in the atmosphere except what it is not here? N2O5. This is not a pollutant. Reminding NO is there and it will react with the ozone layer and convert into nitrogen gas, and it is caused for the depletion in the ozone layer. NO2 is it is responsible for the acid rain. N2 also will be converted into get oxidized into NO. So these all are common pollutant except what it is not here, N2O5. So this is about the what it is not here, P block elements of clear second year. So you have studied P block elements in the first year. What it is, P block is 13 and 14, and S block also you have studied. So this is about the what it is here, P block of 15th, 16th, 17th and 18th group elements.